I'm going to get started. This is lesson 1-2. This video, I'll probably just cut it off at the even and odd functions, and then I'll make a separate video for the one-to-one functions. I'll even go as far as to start with the review we did in class, but the concept that we're focused on is this idea of symmetry, and that's how we identify an even or an odd function. Is whether or not our graph has symmetry across a particular line. Let's see. There we go. So again, the y-axis is one line of symmetry, and if we can look at the left side of the graph and the right side and see that they're identical, we have symmetry across the y-axis. That type of function is what we call an even function. I'm going to skip over here to the origin. If we have symmetry across the origin, it's this line y equals x. And another way, an easy way to look at it really is if we were to flip the graph across the x-axis or the y-axis, it doesn't matter which one first, we flip it across one axis. So the bottom of the graph kind of comes down and the top of the graph goes up. So that would be reflection across the y-axis, and simultaneously then we have to step 2, I guess it's not simultaneous, but step 2 is then take that reflected graph from the y-axis and flip it across the x-axis, and then what we find is our graph mirrored itself. So that's why this is an example of a graph that has symmetry with respect to the origin. All right, moving on, we also talk algebraically what this looks like, and from the table you can see that if we want to test whether something has symmetry about the y-axis, we can look at it graphically, but if we don't have a graph, what we can do is we can just simply replace all of our x's with negative x's in our function. Another way of showing that is right here, f of negative x. What that's saying is, hey, wherever we see an x, we plug in negative x. The question is, once we do that, can we kind of, I don't know, massage the equation and manipulate things to a point where we can reduce the now negative x substituted function and get back to our original f of x. If we can do that, if every sign gets flipped back to its original signage and everything looks the same, then we have an even function. The other option that could happen is we do the same thing. We replace our x's with negative x's. And again, I go back to this method where I look at the function as f of x equals whatever it is we're given, and I replace all of our x's with negative x's. If in the end I can rewrite the same function f of x, but I have a negative sign out front, then what we've done is we've successfully proved that we have symmetry across the origin. We call that an odd function. Now the other method, if we go back here, the other method that is referred to here is, let's say we have like x squared plus y squared minus x plus 3 equals 7x. The problem with that is we don't have this nice easy f of x function being given to us. We have it in a different form, like I said, x squared plus y squared plus 2x. And that's a little bit harder to do this first method where we replace all of our x's with negative x's in the function, because step 1 is getting your equation in that slope-intercept form, y equals mx plus b. So we'll do an example of both methods for the origin, where we would actually replace our x's and our y's by negative x's and negative y's. Okay. I'm just going to do the couple I did on day 2 of this lesson here, but it just says identify the following. So step 1 is, for me, it's replacing all of our x's as negative x's. if we find that we can get this back to the original, we're even. If we can switch the sign on everything, we're odd. If we can't do it and get either of those solutions, we just say that we are neither even or odd. But in this case, what we need to remember is a negative x raised to an even power comes back to equal just the original x to the same power. So our negative x to the fourth is really just x to the fourth. 5 now x squared. Oh, just realized I forgot my hand here. I forgot a negative sign in here. There we go. Negative x. Sorry about that. But now in this simplification, the x squared is back to being positive because it's an even exponent. So what we found is that f of negative x is in fact just x to the fourth minus 5x squared plus 3. And if you look at the original, our f of negative x does actually equal our original f of x. Therefore, we have symmetry with respect to the y-axis. I'll call it y-axis. And if you like, I suppose you could probably put just the word even in there as well. Number 2, we're going to go through, so we can stop here. It says identify the following symmetry. If it's symmetric about the y-axis, we know that it cannot be symmetric about either the x or the origin. So we're going to move on. Here, we're going to do this other method where we just leave it as y squared. I'm not going to do f of negative x equals and then substitute. I'm going to leave it as y's and x's. So y squared equals 4 times negative x. We still have to substitute. Now, the only thing that changed, if I were to rewrite this simplified, is that our 4x became negative 4x minus 12. Now, when you compare this to the original, what you see is the y squared is positive in both, but the 4x term is now negative 4x. And right there, we can tell then there's no way we're going to get around or massage this and move things around and multiply. There's no way for us to get this to either be back to the original or all of the coefficients negative. So at this point, we just say, because this is negative and that's positive, we are neither. So either all of your coefficient signs are the same as they started, or they all end up opposite of what they started. If it is neither of those, you write neither. Okay, real quick. Number 3, we're gonna we'll go back and we'll try f of x. We'll write it this way. You know what? I'm gonna get rid of these parentheses. At this point, kind of unnecessary. And then minus x. So it looks like we're going to simplify, and negative x raised to an odd exponent means that we keep the negative sign out front. So that's going to be negative x cubed over 10 minus a negative x is just x. And if we reduce that one more time, I'm not even reducing, I'm going to manipulate this so that I pull my negative sign out front. What I mean is I'm going to pull a negative out front of x cubed over 10 minus x. And if I do that and I put a negative sign clear out front, then I distribute the negative sign, and what happens is is this fraction negative, and this negative, the negative here is positive. So from here to here, all I did was hold the negative sign way out front. And there's only one reason at this point for you doing that is because really it's asking, I'm trying to show you that this is the same as negative of the function f of x. So f of x here looks like that, x cubed over 10 minus x. If I throw a negative sign, out front of that negative of f of x, it's the same here where I have a negative of the function x cubed over 10 minus x. All that proved is that I took f of negative x and I was able to take f of negative x and negative f of x, and we know that to mean that we are an odd function, or we are symmetric with respect to origin. Okay, the timer on this looks like we're getting short on this recording, but I also feel like we've gotten pretty close to the end of these. So what I'm going to do, I'm going to end this video here. I'll move on to one-to-one functions, but hopefully this is a little more helpful, something you guys can go back on and review the problems. And if I made any mistakes, please see me in class. Let me know if I can correct something. Or if you still don't get something, by all means, please ask in class as well. But again, review this video, pause it, do what you need to, but hopefully this helps get you a little bit more understanding. So next up is our one-to-one functions.